What's up, geometry? Thanks so much for tuning in for another episode of Math with Mullins. Today we're going to be looking at our Unit 1 test review. So we've got a whole bunch of points, lines, and planes, lengths of segments, definitions of angles, distance formula, and just finding missing measurements of angles. So let's go ahead and get started. The first piece of this is we're going to look at a plane. So give two names for the plane. One good place to start is just plane R, using this letter right over here. There's no point next to it, so we can easily say plane R. And then the next thing we want to do is use two linear points and one non-collinear point. So we can maybe say plane A, E, C. So we used A and C from that line, but then E was not included on line, just so we know that it's including that space around it. Three collinear points could be points A, B, and C, just because they're all on the same line there. Coplanar points would just be all in the same planes. Maybe we can say points D, C, and E. Those are all in the same plane. Name 3 points. Anything could be a point in there, so we can say point E, how about D, and then C. A ray just needs an endpoint, so I'm going to say like ray BC, and make sure you include the ray symbol. And then naming two lines, just want to make sure you have the line symbol. So maybe I say like line AC with the 2 arrows on the end. You can also say line L right here. That would be another great way to represent that line. Oops, I put that up wrong spot. Line L. One segment, one line segment, maybe we see like DB would be a good one, just because you want those 2 segments to end. Okay, so that'll be our first section, 1 through 7. The next part, we're going to sketch some figures. So ray AB and line AC. I'm going to start by drawing the line AC, so A first and then C second, and then the ray AB can just come off of that, starting at point A and then ending at point B. For number 9, we want to try to draw plane C and plane D intersecting at line XY. Yours doesn't have to look identical to mine, but what I was thinking is maybe just drawing plane C like this, and then maybe plane D coming across like this, and then their overlapping intersection could be right here, and we can name that XY. Okay. And then go back and label plane D. Okay. Again, that can look a whole bunch of different ways, but that's just one example of what that can look like. For number 10 and 11, we're finding the length of BD. So for this number 10, we're adding 21 plus 7, and we're going to get 28. And then for number 11, we are subtracting and finding the difference between 73 and 17 to get 56. The next few we're solving for x. So for number 12, I know that 2x plus 15 plus the 10 can give me the entire length of x plus 19. So I'm going to combine some terms here to get 2x plus 25 is equal to x plus 19. And then I'm going to do some double elimination. So subtracting my x's from both sides, subtracting 25 from both sides, and I'm going to get x is equal to -6. And then for 13, again, starting with x plus 13 plus x plus 19. So that's from s to t to u, and that is all equal to 12. Combining like terms, I'm going to get 2x plus 32 is equal to 12. Subtracting 32 from both sides, I'm going to get 2x is equal to -20. So x is equal to -10. Okay. Moving right along, number 14 has that bisector. So it says identify the segment bisector of QR, then find QR. So line L is the bisector, which also means that 2x plus 6 is equal to 5x minus 9. So I'm going to just combine like terms here. I'm going to move 2x to the right and move 9 to the left, so that I get 15 equals 3x. so x is equal to 5. 14, find the midpoint of the segment with the given endpoints. Show your work. So this is where we're going to add our x's and our y's and divide by 2. So for that first one, I'm going to do 7 plus negative 5 divided by 2, and negative 4 plus 2 divided by 2. 7 plus negative 5 is 2. So 2 divided by 2 is 1. And then negative 4 plus 2 is negative 2. Divided by 2 is negative 1. So my midpoint would be 1, negative 1. And then for 16, 6 plus negative 10 would be my x's. Divide those by 2. And then my y's are negative 4 plus 10 divided by 2. 6 plus negative 10 is negative 4. Divide that by 2 is negative 2. And negative 4 plus 10 is 6. Divided by 2 is 3. So I'm going to get negative 2, comma 3. Okay. Now we're going to find the other endpoint of the line segment with a given one of those endpoints in the midpoint. So this is where we're going to work backwards. So I'm going to say, go ahead and label my x's and y's, and I'm going to set it equal to the midpoint. So I don't know one x endpoint, but I know the other one is plus 3. And if I divide that by 2, I get 8. And then y plus negative 10, divide that by 2 should give me negative 5. Okay, so first step I'm going to do is multiply both sides by 2 here. So that x plus 3 is all I've got, is equal to 16. Subtract 3 from both sides. I'm going to get x is equal to 13. And then on my y's, multiply both sides by 2. I'm going to get y plus negative 10 is equal to negative 10. So when I add 10 to both sides, I just get 0 for that one. Yep. So x is 13, comma, 0 for that missing endpoint. Oops. Okay. And then for my next one, just working on that the same way. Again, I don't know one x endpoint, but I know the other one is negative 6. So x plus negative 6 divided by 2 is equal to negative 2. And for my y's, I'm going to say y plus 5 divided by 2 is equal to 3. So again, starting off that by multiplying by 2 on both sides. So it'll become x plus negative 6 is equal to negative 4 plus 6 to both sides. I'm going to get x is equal to 2 here. And then for my y's, multiplying by 2 on both sides to get y plus 5 equals 6. Subtracting 5 from both sides, I get y is equal to 1. So my other endpoint would be 2 and 1. Okay. Next up, finding the distance between each pair of points. Show your work. For this one, I actually didn't use the distance formula because I had a picture of the line. So I just thought about a triangle, specifically right triangle. This was 2 units long, and this one is 1, 2, 3 units long. So I considered using the Pythagorean theorem. A squared plus b squared equals c squared. So 2 squared plus 3 squared equals c squared, or 4 plus 9 equals c squared. That's going to give me 13. So what I'm going to do is just take the square root of 13, and that's going to give me about 3.6 for letter C, rounded to the nearest tenth. So I'm going to do that same thing for number 20. Again, making a right triangle here, and then just counting the A and the B sides. This is 1, 2, 3, 4, 5, 6 units long. And over here I have 1, 2, 3, 4, 5, 6, 7, 8 units long. So 6 squared, it could be A, 8 squared could be B, equals C squared for that distance, or 36 plus 64 equals C squared. This is end up going to be real nice. 100 equals C squared, so C is equal to 10. Okay, or your distance is equal to 10. For these though, I did use the distance formula. So remember, we're finding the differences in our x's, squaring them, the differences in the y, squaring them, and then adding them together. So I went from negative 4 minus negative 5 squared for my x's, and then for my y's, negative 2 minus negative 2 squared. Again, double negatives change to plus positives. This is 1 squared plus 0 squared, or 1 plus 0. So I get 1, but I'm finding the square root of that, and so I'm getting 1 is my distance for 21. And then for 22, starting over again, x is 3 minus 3 squared plus y's, negative 7 minus 4 squared. These are just going to cancel out, give me 0. And then negative 7 minus 4 is negative 11. Squaring that, I get 121. And 0 plus 121 is just 121. So the square root of that is 11. Okay? And then we've got 2 more questions for 23. Use the sketch below to answer questions A, B, and C. So we got the complement of COD. Complement means 90 degrees, so here's COD. So the complement of that would be angle COB, because that would add up to be that 90 degree. The supplement of EOA, here's EOA. So supplement of that 180 degrees would be EOD, so angle EOD. And then a pair of vertical angles, you just need to make sure they are congruent and opposite. I would say this angle and this angle are both of those things. So angle AOE and angle COD. Okay. Our last question, it says the measurement of SQR is 2x plus 9. And, or sorry, not our last question, next to last question. And then PQR is 7x minus 7. The entire thing, SQP is equal to 65 degrees. Find SQR and PQR. So I'm going to just say 2x plus 9 plus the 7x minus 7 gives me 65 degrees. Combining like terms, I've got 9x plus 2 is equal to 65. Subtracting 2 from both sides, I get 9x equals 63. So x is equal to 7. So for angle SQR, I'm going to fill in that 7. So 2 times 7 plus 9, or 14 plus 9, I'm going to get 23 degrees for SQR. And then to find PQR really easily, I know the entire thing is 65 degrees, so I'm going to subtract 23 degrees, and I'm going to get 42 degrees for the measurement of PQR. You could still plug in the 7 for PQR, so 7 times 7 minus 7 still gives you that 42. All right, 25, our last question. This is where we're going to talk about supplementary and vertical angles. It says angle 1 and angle 2 are supplementary, 1 and 3 are vertical, and the measurement of angle 2 is 67. Draw and sketch to find the measurement angle 3. So I'm just going to estimate here. We're going to say that angle 2 is here, and we're marking that as 67, but angle 1 is vertical from angle 3. So I'm going to say it probably looks like that. So to find the measurement of angle 3, I'm going to think of these as linear pairs. So I'm going to take 180 and subtract 67 from it, and I'm going to end up with 113 degrees for the measurement of angle 3. Okay, that'll conclude our test review for Unit 1. Hopefully this helped your brain a little bit. Good luck on your test tomorrow, and have a great day. Bye.